In this picture I have a directrix, a horizontal line here at y equals -1, and a focus here at 0, 1. And notice that they're 2 units apart. And I want to find all the points that I'll call P that have the property that F, this is point F, that FP is not equal to PD, but it's equal to it's equal to 2 times PD, where that's PD is the distance from the point directly down to the directrix. Now we've seen before that when this number here is less than 1, it's an ellipse. When it's equal to 1, it's a parabola. And when it's greater than 1, this is the eccentricity, and it's greater than 1, so it's going to be a hyperbola. Now let's see how we actually go about finding those points. We could find points by just kind of saying, well, if I'm 1 away from PD, I'd have to be double that to PF, or 2, I'd have to be 4 away, or 3, I'd have to be 6 away, or 4, I'd have to be 8 away. And when I look for points like that, points that are 1 away from D would be on this line here, and 2 away from PF would be on this circle here. So that would get us these 2 points. Whoops. That would get us those 2 points. Now if I am 2 away from PD, I'm going to be on this line. But if I'm 4 away from PF, I'm going to be 4 circles out. 1, 2, 3, 4. I'm going to be out here on this circle. And I would have this point and this point being, notice how they're 4 away from the red dot in the middle from F, but they're only 2 away from the red line. And if I do the same thing with this one, I need to be 3 away from D, so I need to be on this line, and 6 away from F, which is 1, 2, 3, 4, 5, 6. It's all the way on this circle, which is going to be these 2 points. Now another thing to notice though, so it seems like I'm getting some kind of hyperbola here, or definitely some kind of shape here. Now, one thing we didn't have to deal with before is when I'm 3 away from PD, I could also be down here 1, 2, 3 lines below it, 1, 2, 3. That's also 3 away, but notice if I continue this circle, actually that circle hits it twice more. So what happens is that I actually get 4 points of intersection. Those points are 1, 2, 3 away from the red line, and 6 away. Notice 1, 2, 3, 4, 5, 6 away. So there's 4 points. And actually the same thing happens over here when I was 2 lines below the red, and I was 4 away from the point. 1, 2, 3, 4. I actually got another point on that circle right here. Well, these other points are part of the other branch of the hyperbola. So our hyperbola looks like that. Now, two remaining questions about this hyperbola are: is there a quick way to get the vertices of it, and what's the equation of it? So let me first show you about the vertices. For the vertices, I'm going to draw this line here. Now, let me do this. We know that this red point here is 2 away from, I'll make a yellow point there. And those are 2 away from each other. So, and this is F, and I'll just call this D. So a point that's P that's twice as far from F as it is from D is not going to be in the middle, but it's going to be somewhere over here. So I'm going to call this 2x and this x, so that this distance is twice as big as that. And I can make a little equation, 2x plus x is equal to 2, because that's the distance between the 2 points, or 3x equals 2, or x equals 2/3. So this means that the point will be 2/3 above the yellow, and the yellow is here at y equals -1, so 2/3 above it, we would have another point, add -1 and 2/3, you get -1/3. So it's not so clear from this picture that 0, 0 0, 0 is right over here, so -1/3 is like kind of over there. So we actually have one of the vertices is at 0, -1/3. Now we actually have this other vertex right there, but let's say I didn't know it, I still could get that. This way I can calculate it. I'll calculate it the same or similar way. So here's those 2 points that are 2 units apart, and there's a point somewhere out here, so that this would be 2x and this would be x. It's twice as far from the red as it is from the yellow. In this case, the difference, 2x minus x, would have to equal 2. This is 2. So x would have to equal 2. That means 2 away from, I mean this is 2 also. So 2 underneath the yellow, well, the yellow's here at this point here is 0, -1. So if I go 2 below it, I'm at 0, -3. So those are the 2 vertices. A final thing I can do is find the equation of this hyperbola. It actually doesn't take long to find the equation of the hyperbola. You pick a random point and call it xy, and then use the fact that this distance has to equal, in this case, double this distance. So the distance to the focus, since this point here is 0, 1, and this point is xy, the distance is x minus 0 squared plus y minus 1 squared. That's the distance, that's PF. It needs to equal this distance, 2 times that distance, which is 2 times, in this case, y plus 1. It's always y minus the y coordinate of the where the line is. It's at -1, so it's that. And in one sense we're done, but in another sense it doesn't really look that good, like a hyperbola equation. So I'm going to square both sides. When I square the right side, I get 4, don't forget that. And then in parentheses, I'll square the y plus 1 to get y squared plus 2y plus 1. Distribute the 4 through. Equals 4y squared plus 8y plus 4. And then move everything over. Subtract the 4y from both sides. You get minus 3y squared. Subtract the 8y to get minus 10y. Subtract the 4 to get minus 3. And we could leave the equation in that form.